Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of domain and range. This is standard A.2A in the great state of Texas, and we are using item number 25 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a football player sprinting at a constant rate. So we've got a linear function here, represents the distance in yards as a function of the time in seconds, and we're looking for the range. So let me open up my graph draw feature so I can draw all over this here, increase the transparency. So I'm going to keep it just like this so we can kind of see what we're doing down here. And so we're looking for this range. That's kind of our key term. And when we're looking at range, we always need to kind of pair the two terms together. So the two terms that always go together are the domain and the range being what we're looking for. So let's define both of those. So the domain is the set of our independent variable values. So those are the values we always start with when we're looking at a function. And for the most part, those are going to be our x values. But sometimes we replace x with a letter from the story. So in this case, it's time in seconds, right? That's going to be our independent variable value. So our domain is going to go right here from left to right. But sometimes they might replace the x with a t for time. So if that's the domain, then that means our range is going to be our set of dependent variable values. And that's what we are looking for in this problem. And for our sake, it is going to be the y values, right? And you can see that kind of up here, right? We've got that y up there, but sometimes it's not always going to be the y. They could replace it with the d for distance. Sometimes they even just put f of x, right? So the function of x is going to stand for our dependent variable values. So those two, domain and range, right? The way to keep them separate in your mind is d comes before r alphabetically, x comes before y alphabetically, right? So we're looking for the range of this function. So you see that we've got two circles here that are closed. So that's going to be important. So we're looking at our domain, not our domain, we're looking at our range. And we see that it is going to be on our y-axis. That is our dependent variable values. And it's going from that 0, and we're not necessarily looking left and right, that's our domain. We're looking up and down. And since we've got closed circles at 0 and 80, so it looks like we've got a line segment, we need to include those two, right? So we're going to use, less than or equal to or greater than or equal to. If we had open circles like this, that means we would not include the 0 or the 80, and so we would just do the greater than or less than, but not have the equal to. So let's see what our y looks like. So I'm going to build it like this, y in the middle. So y is greater than or equal to, and even though it looks like it's got the less than symbol, it's because y is on the right. So you read it from the y towards whatever you're building. So it's greater than or equal to 0. So that's where it's going, and we're looking up and down just on the y-axis. And the highest that y goes is going to be 80. So it's going to be less than or equal to 80. And so sometimes we'll build that as an expression, right? So you see that right here with C. Sometimes they'll say that in words, and you have to just read it written out. Now this is our range. So I bet that if we find our domain, we'll probably find that as one of our answers, right? That's our x. X is also greater than or equal to 0. But take a look. The highest that the x goes, the domain, is going to be 9. So it's less than or equal to 9. And you notice this right here. So that's that b. But we're not looking for that. They also just replace the x with the y, put that there for a. And then d is also very similar. They just replace the y with the x. But our answer here is C.